Faiza, am I audible? Please do respond. No. Rajita, am I audible?
Yes, sir.
Okay, so we were doing this chemical kinetics.
So last class I wasn't present, so I'm not really sure.
Can you repeat it again?
Last class I wasn't present, so I'm not sure.
Okay. Last class you were absent, so did you revise this chemical kinetics?
No, sir. I didn't know.
Okay. So which chapter you have revised recently?
Sir, either aldehydes and ketones.
Please do this.
So can you explain the fifth question once? I think the question is missing. Sir.
Yes, just wait a minute. Okay, so you are asking the question number 3, right? Yes or no?
No, sir. Five.
Fifth one.
Yes, sir.
Okay,
It
so
says corresponding carbonyl compounds.
which one of the following can be oxidized to corresponding carbonyl compound? Can be oxidized. So first of all, okay, wait a minute. Let me check the question. Corresponding. Just wait a minute. Okay, very good. So you are going to write all the structure and then you can think of it. 2-hydroxypropane, that means this is your 2-hydroxypropane we can write, right? IUPAC is not written correctly. It should be propane 2-ol, right? The next is nitrophenol. So you are going to write this phenol and ortho it is so NO2, right? And then you are going to write phenol. Phenol, you know the structure. This is your phenol. And after that, you can see you have propane 2-methyl 2-hydroxy. It is given like that. So you know that tertiary alcohol cannot be oxidized, right? Tertiary alcohol cannot be oxidized. So the oxidation cannot take place and it will not be converted into carbonyl compound. Again, you can see OH. OH is there. You are not going to oxidize this as it is uh, not going to be oxidized because this doesn't have hydrogen. This also doesn't have hydrogen, this carbon. That's why it is not going to oxidize. In the same way, phenol, if you are going to oxidize with corresponding, so it is not going to take place. It will be converted into benzoquinone or something. And this can be easily oxidized. If you are going to use oxidizing agent like PCC or something, this will be converted into ketone carbonyl. So the correct answer is A. Aisha, will you be able to solve this aldehydes? Have you revised that?
Yes.
Okay. Rajita, have you got it?
Yes, sir.
Okay. Mhm. Mhm. 3A, that is correct answer, Aisha. 4B, that is also correct answer. 5A, that is correct answer. 6, it is C, that is also correct answer. 7, the catalyst used in this, so B, that is correct answer. 8, ketones oxidize into tertiary. Wait a minute. Oxidation of this? No. Hydrolysis of this stuff? Ketones can be obtained in one state. By oxidation of primary alcohols? No. Oxidation of tertiary alcohol does not take place. Reaction of acid halide with alcohols. If you are going to do reaction of acid halide with alcohol, yes, it is. So it will be, wait a minute. Ketones can be obtained in one state. Okay. If we are going for this, 8, that is your acyl halide followed by alcohols. Okay, this will bond positive, negative. Okay, this can be okay, no problem. This won't be in one single step. We need to follow single step. So we can easily do this. Tertiary alcohol, if we are going to take tertiary alcohol. So tertiary alcohol, let's say this is your tertiary alcohol, OH, CH3, CH3. But if you want to oxidize this, you need a very stronger oxidizing agent with extreme condition like temperature should be very high. Then this will be converted into ketone. This whole quantity will be oxidized into CO2. This quantity oxidized into CH3, COO, CH, and H2O will also be eliminated. Generally, this tertiary alcohol cannot be oxidized, but when you are going to give a very strong oxidizing agent, very strong oxidizing agent, along with high temperature, elevated temperature, then it can be oxidized into ketone. So the answer will be C. And the last you can see pinacolone is.
So, one question. For the eighth one, oxidation of primary alcohols with strong.
That will give you always aldehyde. Like if you have alcohol like this, if you are going to use mild oxidizing agent, you will be getting aldehyde. And if you are going to use a strong oxidizing agent, you will be getting carboxylic acid. With primary alcohol, you will get this. With secondary alcohol, you will easily get ketone by using mild oxidizing agent or a strong oxidizing agent. But with tertiary alcohol, you need a very strong oxidizing agent, not mild oxidizing agent, plus elevated temperature. Is that clear?
Yes, sir. Thank you.
Pinacolone, you can see the compound you should remember. It is a reaction which you will study in higher classes if you are going to study chemistry. So this is the structure of phenol. You know that this is your basically, if you are going for IUPAC, it will be 3,3 dimethyl butane 2. Okay. Oh, let me know when you're done with this. Can you change the slide, Rajita?
Yes, sir.
Have you got pinacolone, Aisa?
Yes.
Okay, last questions options I'm going to give you. Here I'm going to go through this. This is the last questions option, question number 2. Let me know when you are done with this. Any answer?
There is the first one, B.
10th, and yes, it is. Yeah, Rajita, you know that if you are going to do acetone, that is ketone. Ketone with Grignard will
No,
always
sir.
be possible.
I said B. Is it B? Oh, yes.
Yes. 11 1. What is the answer? You need to write the benzaldehyde structure and acetophenone.
C.
If it is having B or C, what did you say?
C. I said C.
C, cross aldol, because alpha hydrogen is present there, right? And dilute NaOH is there. In Canizaro, we use what? We use concentrated. What is the answer for 12? As you can see, there is a compound which you are going to use copper at 573 Kelvin, which is oxidation. So it converts into A, and which is giving you silver mirror image. That means it must be aldehyde. You can see. And oxidation of aldehyde. Go back to this reduction, it becomes alcohol, because if you are going to oxidize primary alcohol, you will get aldehyde. So this is your alcohol, which is X-ethanol, which is oxidized into aldehyde, which is propanol. Sorry, not propanol. Ethan. This is your ethanol, and this becomes ethanol. After this, you are going to use OH minus and heat, which is aldol condensation. Aldol condensation. So for aldol condensation, I'm going to write this trick. This is your from one mole, you are going to use this oxygen, and from another mole, what you are going to use is alpha hydrogen. Alpha hydrogen, and remove this remove this H2O. You will be getting CH3 and then CH, double bond CH, and then comes your CH3. Sorry, just wait a minute. This I have written wrong. This is your CHO. So this becomes CHO. So you can see the name will be 1, 2, 3, 4, which is basically but 2 in 1 all. So, and if you are going to use this on ethanol with this, you need to react this and it becomes semi-carbazone. So the answer is B. Very simple. This is ethanol, ethanol. A is ethanol, X is ethanol, Y is due 2 in 1 al, and Z is your semi-carbazole. When you are going to react this aldehyde with this amide, you will get that. What is the answer for 15? 15, you can see the product formed by the reaction of an aldehyde with primary amine, that is called your escape base. If you are going to have that an aldehyde or ketone, you can take aldehyde like this. And when you are going to react this with amine, what you need to do is very simple. You are going to remove this H2 and O, that is H2O. And if you are going to write it again, H is there, double bond, sorry, N and then R dash. This is your escape space. So the answer is escape space. What is the answer for 13? 13, you can see, undergoes aldol condensation. What cyclohexanone? I'm going to show you what you need to do for aldol condensation. That means heating will also be there. First of all, you are going to write this is your cyclohexanone. So this is the first mole, and another mole that I'm going to write is this. This is also your cyclohexanone. You can write in any way. And this is your alpha carbon. This is your alpha carbon. I'm going to use this. What you need to do for directly aldol condensation, you just need to remove this water and add this carbon double bond to this. So what you will get is very simple. This is your cyclohexane, which is doubly bonded, and it will go like this and double bond, something like this. So what will be the answer? You can see according to the option, the answer is, I think A is the correct answer. Is that correct? Clear? So this trick you can use directly to calculate the aldol condensation product. So A is the correct answer for it. Is that clear, both of you?
Yes. Yes, sir.
Do this. Any answer?
So the first one is D.
First one means 16, right?
Yes, sir, 16.
Oh, that is correct answer. 16 is B. If we go for 17, what is the answer? Oh, very
Let's
good.
see, I'm not sure.
17, treatment of cyclopentanone with methyl magnesium. Methyl magnesium. Sorry, methyl lithium. CH3Li gives which of the following species? So very simple it is. You know that this will be going like this, negative, and there will be positive, right? And this is positive, this is negative. So what we can write is very simple. This will be attacking this. So it will be something like this. O negative is there and there will be CH3. So cyclopentanoyl anion is there. Cyclopentanoyl anion. So for 18, any answer? Enolic
B.
form, D is the correct answer. For 19, any answer? Reaction of carbonyl compound with one of the following reagents involves nucleophilic addition followed by elimination of water. The reagent is very simple. It is hydrocyanic acid. Hydrocyanic acid. If you want to see the reaction, you can see carbonyl. I'm going to take this hard as with reaction of carbonyl compound with one of the following reagents. So if you are going to take this NH2 NH2, elimination of water took place. So you just need to remove H2 from N and O from this. You will be getting the answer. Yeah. So you can remove this and you can remove this and you will be getting RC. R dash is there, double bond N, and N is connected with NH. N is connected with NH. After that, you can do again. Just wait a minute. You can do this step. Nucleophilic addition reaction involves. Okay. So first you are going to protonate this. If you are going to protonate this, you will be getting this. There is this. This will be going like this, and this will be attacking on this. The reaction will be RCOH, and here it becomes R dash, and here NH2. H from here attacked basically, so it becomes NH. And now you can remove water. So you will be getting directly. You can do as well. So the answer is hydrocyanic acid. After that 20, which one is most reactive towards nucleophilic addition reaction? If you want to add nucleophile, which one is the answer? Nucleophile wants to attack on this, so very simple it is. So if a nucleophile will attack, that means there should be electrophilic center. CHO is there, that will withdraw electron, that is good. All have CHO, all have CHO, and this is also going to withdraw electron because ketone is there. And CH3 is there, which will support this. There is no support, there is no support. But if you are going to look at the option D, this CHO is attracting or withdrawing electron towards it, and this is withdrawing electron towards itself. And nucleophile, that means the most electrophilic compound here will be this one because both the group attached is withdrawing electrons. So the answer will be D. Is that clear, Aisha? This is your wrong answer, right? So nucleophile wants to attack, that means it wants to go to that compound faster, which needs more electron, which is in requirement of more electron. So there is only one electron withdrawing group, one electron withdrawing group, there is electron withdrawing group, plus I is there. This will be the least, and this will be the maximum. Can I change the slide? So the answer is D. Just wait a minute. Please do this. Any answer? Oh, very good, Aisha. Rajita, what about you?
I'm not really sure.
No, what did you say? You're not sure. So see, very simple. This is 38. Nucleophilic addition reaction. It should be less hindered. So always aldehyde, generally aldehyde will be greater than ketone when you are going to see the reactivity. Now ketone is there, so you are going to eliminate it. Now you have this aldehyde. Now this is less hindered because one alkyl group is there, there is two alkyl groups, so the answer is C. Is that clear? Now
Yes.
you can see A and B you need to calculate, right? So first of all, R C double bond R dash is there. So what you are going to do is very simple. You know that this is also nucleophilic addition reaction. HCN in the presence of KCN. So what you need to do, this will go like this. So this is plus, this is minus, this will be going to this because this is negative, this is positive. So Cn will be coming in. So what you will get as A, RCOH is there, and then comes your Cn, and then comes your R dash. And after this, what it is given, okay, B we need to calculate, and C already given. The product is given R dash OH and CH2NH2 is given like this. You need to tell which one is B. So A we already connected that it is something like this RCCNH, right? So this is the correct answer. This is A and this is A, which is same. We need to go for B. Now B, you can see Cn is there and Cn is converted into CH2NH2. That means basically we are reducing it because we are adding hydrogen. And which one is your reducing agent? So you can see aluminum, lithium aluminum hydride, which is a reducing agent. So this is your Cn, it will be added hydrogen, another will be bond will be, so it becomes CH2NH2 at the place of Cn. So A is the correct answer. Is that clear, both of you?
Yes, sir. Yes, sir.
Please do this 40 question. Very simple things. Very good, Aisha. Uh, Rajita, can you recognize this reaction? See, Rajita, what you need to do? M-chlorobenzaldehyde. So you are going to write the structure first. M-chloro, metachloro, right? So benzaldehyde, this is your benzaldehyde and metachloro. And it's treated with 50% KOH solution. That is okay. The product are very simple. You can see there is no alpha hydrogen, and this is their KOH. So this is your Cannizzaro reaction. And in Cannizzaro reaction, basically, disproportionation reaction is going to take place. Okay, disproportionation reaction, that means this aldehyde one time it will oxidize and another time reduce. Very good, both of you. Go for question number 451. Very easy it is. or is wait. Rajita 51, you can see nucleophilic addition, that means it should be less hindered, then it will be more. Decreasing order we need to go, right? So if you are going to pentanol, pentanone, you can see two ketone is there and one aldehyde is there. So aldehyde is at the top, right? It will be the most reactive. After that, 3 pentanone, and then no, 3 pentanone. That means this is the scenario. Both side you are getting alkyl group, bulky alkyl group, and you can see cyclopentanone is there like this. So basically, in between 3 pentanone and cyclopentanone will be more reactive. So the answer is C, not B. And acetone reacting iodoform, we use NaOH. And this benzaldehyde reacts with ethanoic acid, KCN, to give what? Ethanoic acid. Very good, Aisha. So very simple. This is if you are going to use benzaldehyde in KCN. So you need to take 2 mole of this and you will be getting this. Basically, I'm going to show you. This is the first mole. And benzaldehyde it is double bond H, double bond H. And I'm going to take another mole of this benzaldehyde, C double bond O and H. Heat and casein is there. Alcoholic casein is this. So you just need to remove this. Hydrogen is there. Just put in. So the product basically formed here will be like this benzaldehyde casein. This will be reduced. OH, hydrogen is there, and this will be oxidized. So you just need to remove hydrogen. So this will be the product. So the answer is B. Is that clear? And this is called benzoic condensation. Both of you, Rajita and Asha. Rajita, we already almost completed chemical kinetics in the last class. Only for you, I started this chapter. Let me know which chapter both of you are going to do so that we'll be able to do in the next class. Aisha, Rajita.
There is this chapter only.
This chapter. Okay. Aisha, this chapter we are going to do, okay?